today I want to talk about what are the new innovations or what we have been doing with HeatWave, right? So let me get started. As you may know, we started with MySQL as a service. So we offer the OLTP capability through the MySQL Enterprise Edition database. And then what we find out is that a lot of our customers is actually using the MySQL data to do not just for OLTP, but actually they want to analyze the data, they want to do predictive analytics, and then of course now with the generative AI, right? So what we have started on the journey with HeatWave is that besides OLTP, we want to enable our MySQL customers to do analytics on their data. So we have added HeatWave, the in-memory hybrid columnar processing engine, onto the service offering. And then, as I said, right, people not just want to do historic data to do analytics, but they also want to do prediction into the future. So what we have added as well is the machine learning capability, where basically based on the data that you have stored in MySQL, you can also do prediction, whether it is classification, regression, recommendation system, forecasting, all kinds of capability or tasks that we want to enable the customers to use the data to do predictive. And then later on, like as data size has grown, right? Like I think mobility, modernization of infrastructure really enable our customers to be able to start storing all kinds of data into their data lake, right? We are starting to see customers really building on that, and then the volume of data has become much larger. And now we're talking about not just the data that is stored in database, but also like any unstructured data, semi-structured data that they just like freely getting from the apps, getting from social media, and then they want to basically correlate all of this data with their OLTP data as well, right? Because that's where their most important customers' data stored in the OLTP database. And then they want to basically correlate and apply the same analytics and machine learning across all of this data. And then that's where we have extended our HeatWave service to be able to process data outside of MySQL and then be able to process data directly on object storage. And then with the latest innovation or added features, right? We have added generative AI and vector store capability within the service so that we'll be able to allow our customers to be able to use natural language to interact with their data, whether it's on OLTP or on the object store in data in object storage. So as you can see, right, basically what we wanted to do, allow the customers is to be able to, from transactional all the way to generational, right? From structured, semi-structured, and unstructured data. So overall, all in all, right, we want to be able to allow customers to use HeatWave as a service to be able to process their OLTP, their analytics, machine learning, as well as generative AI use cases across data that is stored on MySQL InnoDB, as well as data that is stored on object storage. The other thing we have done, right, like as Wim yesterday talked about, we definitely want to make sure that MySQL, we keep innovating in MySQL and then keep making MySQL available anywhere for our end user. So we have MySQL self-managed, whether you're using Community Edition or Enterprise Edition. From a managed service perspective, which is HeatWave, we have made it available on OCI. So OCI is available in all commercial region, in dedicated region, as well as in Alloy. And then we are also have it available on AWS as well. So this service on AWS, we run it natively on AWS infrastructure. So if you have already application running in AWS and then you cannot move to OCI, you have the option to use HeatWave to run off this use case using HeatWave on AWS. With Azure, our approach is a little bit different here. We're using the Azure Interconnect. So we have a great partnership with Microsoft, so where we can basically set up interconnect between the two data centers from OCI as well as Microsoft. So that's the latency between the two data centers is really small. So we've found a lot of customers who are actually have their workload run on Azure and then be able to use HeatWave through this interconnect and then still available to take advantage of HeatWave. So now I want to go into a little bit of each of the topics, right? The focus area that we enable our customers. So analytics, Gen AI, OLTP, and multi-cloud. So what we have done recently on warehouse and what we are planning in the future, right? Basically what we want to do is focus on allowing customers to be able to use HeatWave for more of the analytic workload. Why is that? Because OLTP, we base on MySQL, right? MySQL has been designed for OLTP only, mainly. And then so some of the capability that you typically need for OLAP use case are not available on MySQL. So what we want to do is to extend MySQL to be able to support OLAP workload, more specifically on some of the OLAP functions, and then as well as capability where enable customers to be able to process large amount of data very quickly. So for workload, for example, recently we have added JSON function support, store procedures, triggers, and timetable, which basically enable customers to use HeatWave to process more efficiently about, for example, pre-processing the data for reporting, right? A lot of our customers do that within MySQL, and typically it takes a long time. So with HeatWave now, adding this capability into the in-memory processing engine, now you can process this process much faster. Performance has been one of our focus with HeatWave, that we want to provide the best performance and best price performance across the board for all the offering or the features across HeatWave. So we have been, for example, adding partition tables, auto zone map, or some of the machine learning capability where basically we automatically improve the custom system performance so that you don't need to do anything, and then we can automatically improve performance. The last one is manageability, right? So we want to make it much easier, not just on the OLTP management side, but also on the HeatWave side, right? So adding more capability, basically automatically manage the data within the system so that you don't need to worry about it. So some of the example, for example, since HeatWave in-memory processing engine, right, is an in-memory system, we need to have the data stored in the HeatWave memory. So we automatically load the table from InnoDB into the in-memory hybrid columnar so that we can automatically accelerate the query for you, and then you don't need to worry about which table you need to load, which table you need to unload, and then automatically get that performance improvement by that. The other stuff that we have done, for example, is to have an integration with OCI database management so that you can monitor the metrics or the performance of the queries running within HeatWave, and then be able to see what is the issue there, or create alerts and notifications based on those. The other area that we are focused on is the lakehouse part, right, where basically we want to be able to allow our customers to process more data that is stored on object storage. So pre-processing is one of the main things that we want to allow customers to do, and then this feature basically enable us to be very quickly export data or query results into object storage. So the benefits of doing this is that now if you have any downstream application where you need to process the data further, for example, we have a customer who has a lot of data, and then they're really looking for best performance and price performance solution to pre-process the data for their downstream machine learning use case, right? They have their own machine learning environment already. So they use HeatWave to pre-process this data, and then they put the result into object storage, and then the downstream machine learning application can use the data to do machine learning training or prediction. So with that, right, so lakehouse is enabled by be able to, basically with HeatWave and HeatWave lakehouse, we can process structure, semi-structure, and unstructured data across the board from OLTP and object storage. So with HeatWave, it is enabled by default. We are able to support concurrent loading of tables. So one of the things that we find out is that because the data size in object storage has become so huge, right? In order to process this data, loading the data into the system for processing can also take a long time. So we have already excelled in loading large amount of data within a single table. And what we have done recently is to enable concurrent loading of the table so that if customers have smaller tables or smaller size tables, we were able to also load these tables very quickly inside the system for processing. The other stuff, for example, we're planning to do is to do elastic resize of the HeatWave cluster. So currently, when you need to upsize the cluster, right? Whether your data size is getting larger or you want to have better performance, since our system is designed very scalable, you can do that getting the same performance or get a better performance when you upsize the cluster. So what we do here is that we are resizing the cluster elastically so that it will not affect your workload when you upsize or downsize the cluster. Zone map is another features that we do to basically enable faster performance. So what it does is that when we load the data into the HeatWave in memory, we collect statistics, right? Some metadata around the table, around the data. So zone map allows us to basically, for example, if you have a lot of like filters on queries, where we can basically use zone map to filter some of this data chunks that we store in HeatWave, and then allow us to be able to process less data and then enhance the performance of the query. So the other stuff that we have is change propagation. So when you have new data, or when you're updating data that is stored in object storage, we can automatically detect those changes and automatically propagate into the system, so that you can always get to the near real-time data when you want to, either for analytics or for machine learning. On the generative AI side, right, just on a high level, what we have offered in HeatWave Gen AI is, on the high level, 3 main features, or 4 things that we have offered. One is the vector creation. So what it means is that we can automatically detect the documents that is stored in object storage. We do the automatic chunking of the documents, and then we automatically embed the data into a vector store, and then the vector store is stored within the HeatWave cluster. The second thing is that we provide a very performant vector processing or similarity search. So you can use that to search your documents much better, right? So for that. The third one is generative AI capabilities. Specifically, we support in-database LLMs. So those are quantized LLMs, smaller, and then it can be run on our HeatWave cluster using CPU instead of GPU. So it helps to reduce your cost and have consistent results across different location, right? If you need to deploy your application across cloud or in different region. We also support OCI LLM as well, of course. And then and then the last one is that we have a VS Code plugin. So for developers who wants to create or use our Gen AI capability to create use case for their application, they can very easily use our VS Code plugin and then develop application there. So here's on the high level, right? Basically what we have is that enable our customers to be able to very easily end-to-end pipeline to create generative AI use case for that. The other thing I want to mention on this here is that we also have a JavaScript capability, right? So on MySQL, we have added the JavaScript store procedure functions or store procedures support on that. And we've seen a lot of customers actually using the JavaScript capability in conjunction with generative AI. So for example, some of the text manipulation before or after the LLM, and then we can see a lot of synergy there. So that's another area that being a single service, having multiple capabilities allow customers to basically kind of mix and match our capability to be more very flexible for their use case. So one of the things we have really tried to do is to simplify the usage of GenAI, right? Because GenAI actually typically involve creating the vector store where you can bring your enterprise data into the system so that you can use your enterprise data for the context for LM, and then use the vector store with the LM with the RAG capability, right? So as you can see here, whether you need to create a vector store or the second step usually involve a lot of steps, whether it's through your application or through another service. So what we have done is that we really simplified the usage of generative AI so that if your developers or doesn't really know too details of the LMs, you can still make use of HeatWave. So for example here, right, creating a vector store is just simply a SQL call. And then similarly for using the vector store with LM, also similarly, it's a very simple ask your questions, and then we can automatically do the behind the scene, right? Calling the, embedding the questions, doing the similarity search on the vector store based on the question, and send the context to LM for the answer. The same capability where I talked earlier with Lakehouse, where we can incrementally update the changes that you did have the files on object storage applies to GenAI as well, right? So with vector store, we ingest the data from object storage for unstructured data, for example, PDF, Word document, HTML, and such. And then so if you make any changes or if you add or delete any of the data that is stored on object storage, we can automatically detect and update the vector store as well. Just from a comparison perspective, right? If you look at here, with similarity search on the right-hand side, as you can see, we are much faster. So we use the same capability that we use on the in-memory hybrid columnar engine to apply to the similarity search. That's why we can, you can see the same trend here, whether it's OLAP or similarity search in the context of GenAI. We're much faster than BigQuery, Databricks, and Snowflake. In the vector store creation as well, right, as you can see, because our system is designed really to scale, and then with the cluster of nodes with HeatWave, we can definitely scale as you have more and more documents, right, you can scale really, really well as well. So you can see here when we're comparing to Amazon Bedrock, we are much faster across the board for different type of documents. Right, this is just a summary of what I have just talked about. This one is more specifically talk about the in-database LMs. So as you know that we are running the LM within our HeatWave cluster, which is based on CPU. So what we, and then definitely CPU is not as performant as comparing to a GPU, right? So we spend a lot of effort in trying to improve the performance or the latency of the LLM that's run within the HeatWave service. So as you can see here, depending on the prompt size, we have made significant improvement in terms of the performance of the latency of the LLM. This is one of the use cases internally that we use for HeatWave GenAI. So with support, right, typically when customers file SR, support needs to basically understand the customer's issues, search if there's any existing similar issues, and then how on the documentation or like any of the existing knowledge base, how to address this issue. So typically that can take some time, or it can take longer time depending on how familiar the support is with the issue. So with GenAI, we are actually able to improve this by ingesting all of the information about our existing knowledge base, our documentation, any of the existing SR information, how we have addressed these issues, into our vector store, into HeatWave GenAI. And then when a customer's issue SR comes in, the support guy can very easily just ask a question about the issue that the customer is seeing and then gets the relevant information so that they can respond to the customers or help the customer much easier or much quicker. The other thing that we have done is actually on GenAI side, we also have a feature called machine learning or auto ML, auto machine learning. What we do there is to automate the machine learning pipeline or life cycle, right? So that if customer does not have the machine learning expertise, they can still use HeatWave, right? So basically what we do is that we automate the process from, like on the right-hand side, you can see from pre-processing all the way to hyperparameter tuning. And then we can run different tasks based on the customer requirement. But then the focus we want to have the customer is to focus on the business use case. What is that they're trying to solve? What are the data that they need in order to create a good machine learning model, right? And then that part is where basically we have seen a lot of customers still spending quite a lot of time. And then what we have done is that we have used GenAI to simplify this process. And I want to right now introduce you to Sarah, who is from our machine learning and GenAI team. She's going to introduce you to this new feature that we are coming up, which can help our customers to simplify the process of translating business problem into a machine learning task. Please, Sarah.
Hi everyone, my name is Sarah and I'm a member of HeatWave AutoML team. As you know, HeatWave AutoML is super easy to use, and now we're introducing a new feature for ease of use called NL to ML, or Natural Language to Machine Learning, which provides step-by-step guidelines on how to use ML to address a business problem. And NL to ML has been created using the generative AI capabilities of HeatWave. Let me quickly walk you through an example of using NL to ML for food delivery businesses such as Uber Eats or ETZ. A common use case in food delivery business is to predict the food delivery time. So I asked NL to ML, give me a training query to predict how long it takes to deliver food. As you see, NL to ML could come up with a fully correct and executable training query. It automatically sets the right table, right target column, and what is really interesting is that it can automatically set the right model as regression, right task. Basically, it can automatically map a business use case to an ML use case, which is really cool. And then I asked, how can I evaluate this model? As you see, NL to ML could come up with a correct scoring query that can be used to evaluate how good the model is, and it also provides some explanations that which scoring metrics is more suitable to use for the regression task. We can ask for other queries such as inference and also generating explanations, and NL to ML can come up with really useful queries that users can execute within the MySQL database. And it's not just query generation. NL to ML can be used to also answer general questions about HeatWave AutoML. For example, here I asked, how many models can I load into HeatWave cluster, or is there any limit on the size of training table? As you see, NL to ML provided fully correct responses that are according to HeatWave AutoML documentation. So instead of user going and looking for answers within the documentation, they can just type their questions here and get immediate response from NL to ML. And also, another cool feature of NL to ML is that it can help users with debugging purposes. For example, here, I just typed an error here and mentioned, okay, when I try to train a model, I got this error. What does it mean, and how can I resolve it? NL to ML perfectly explains why I might be getting this error, and it also provides step-by-step resolutions that I can use to fix the problem, which I really find it useful. This was a quick overview of NL to ML, which has been created using generative AI capabilities of HeatWave. If you have any questions about the tool, or if you're interested to trying it out, I will be staying at room 105. Feel free to stop by to give it a try, or I will looking forward to get your feedback as well about the tool. Thank you so much for your time.
All right, so, okay, sorry. Yeah, so please, if you're interested in trying the NL to ML feature that we are going to release pretty soon, come to room 105. Sarah will be there helping you guys, or giving you a demo, or you can try it hands-on as well. So The next thing I want to talk about is OLTP, right? So definitely one of the things that we want to focus on is to improving MySQL, which a lot of our MySQL users is using MySQL, right? So one of the things that we have done is we have added this hypergraph optimizer into MySQL. So hypergraph optimizer has been used for the last one and a half years in the HeatWave side, where we have the in-memory columnar engine. We have been using that for OLAP kind of use case. So now we make it also available on the MySQL side as well. So what does this optimizer really do is to help to improve query plan, specifically for queries that have joins. So this allows us to basically have a much larger search space so that we can find the optimal query plan for the join queries. So it can improve the execution plan and hence improve the performance. So what we have seen so far is that with our testing, right, this is using TPCH and TPCDS, which are the standard benchmark for more like OLAP queries, right, more complex queries. So if you want to run more complex queries with MySQL, with the hypergraph optimizer, we can see that as comparison, right, with MySQL, with hypergraph, with Aurora Postgres, as well, you can see that we can run faster for both TPCH and TPCDS data. The next thing is that we have also improved bulk load. So MySQL, when you need to import a large amount of data into InnoDB, it can take quite a lot of time. So what we have introduced earlier is a bulk load feature, basically enable customers, if they have a large amount of data in CSV, for example, we can increase the load time with the bulk load feature. So earlier was like a more, so with this new improvement, basically what we have done is to basically support more file format, right? For example, compressed file format, vector data type, JSON, blob, and other data file formats. So basically expanding the capability of bulk load so that we can support more file format and data type. And here's a comparison, right? We are comparing with using MySQL, regular load versus bulk load. As you can see it here, we can improve the performance much better when using bulk load. The other thing that we have done is the replication, right? So we want to improve the failover performance and resiliency. So what we have done is that when you have a HA system, where it's a 3-node system, when we need to do a failover from primary to one of the secondary, so we make it aware so that in case the two secondary, one of them is lagging more behind than the other one, we will pick the primary where, we'll pick the secondary where the lag is less, so that when the failover time can be much less, right? The second one we have done is that if there is a secondary which we have problems, we will automatically replace the secondary and then rejoin the new secondary into the group, so that's making the service availability much better. The other thing is we enhance the manageability of replication. So we have done flow control monitoring as well as the applier statistics. So these additional metrics allows you to be able to get a better sense of why, if there's a replication lag, or how our flow control can help in some of the cases, right? So that you can decide how you want to configure the MySQL or have better monitoring capabilities so that you can understand your workload better. So all in all, right, the focus of OLTP that we have done or we continue to do is to basically reduce the downtime, make the service more resilient, and make it more flexible. So as you can see here, right, from the downtime perspective, because we have done a lot of work recently to improve the failover downtime, and then you can see here from unplanned, we are 7x better now, and then with the planned downtime, we are 6x better. From the resilient perspective, earlier we were talking about, right, the automatic replacement. If there's any issues with a secondary, we'll automatically replace so that you don't need to worry about it. Or when there's a failure happen, then the HA system is healthy. From the flexibility perspective, right, we are adding enabling. Recently, we have announced the capability where you can specify a DB system or a MySQL instance, whether it's a read-write or read-only. We see a lot of use cases where customers want to make the MySQL system to be a read-only so that there's no writes allowed, and then make sure that, like, typical use case, for example, is a reporting system, right, where they want to use MySQL, for example. So some of these capabilities we have added for OLTP. From the inbound application side, we have also done a bunch of work as well. So TPS on read replica, for example, or some of these double writes capability, right? So this allows us to be able to improve the TPS as well as the channel lag time as well, if you can see here. Earlier, we said that we had added support with JavaScript store procedure support. So we have now added like library support as well as GenAI and AutoML specific API, so that it's much easier for you to use. As I mentioned earlier, right, we've seen a lot of synergy with JavaScript and GenAI and AutoML. So we want to further improve that to enable users to be easily use these two capabilities together. The other feature that we have is already available is auto-indexing, so recommendation based on machine learning capability to look at your OLTP workload, suggest secondary indexing to improve OLTP workload. So that is already there. What we have now will come out soon is that we'll add notification if you want to receive anything, right? Like running your MySQL on OLTP, we can automatically send you notification in where we find your system can get better performance if you apply secondary indexing. So the last thing that I want to talk about is about the multi-cloud. As I mentioned earlier, we are available on HeatWave on AWS natively, running inside the AWS data center and infrastructure. What we have done is that we have introduced GenAI not just on OCI as well, but also on AWS. So AWS, we have the integration with AWS Bedrock, the same capability that we can apply on OCI has the same capability on GenAI as well, on AWS as well. So that includes vector creation, vector processing, in-database LM, the same database, in-database LM that is going to be available across both OCI and AWS, as well as the integration with AWS Bedrock. So in case you want to call out to using LMs from Bedrock, you can do that as well. On the AWS side, the high-level focus that we have been working on is on OLTP mixed workload and ease of use. So HeatWave on AWS is introduced a bit later, about 3 years ago. So there are some capabilities that we are still working on to try to catch up. So for example, high availability, AWS private link support, and then as well as directly importing data from S3 into InnoDB. That's some of the features that we have added recently. On the mixed workload side, the integration with Bedrock that I mentioned earlier, the same capability where I mentioned earlier where you can use lakehouse to export data into object storage. On AWS, we have done it with S3, faster reload, and time when the bulk load capability where I just talked about also is added to HeatWave on AWS as well. And then on the ease of use side, since the console on HeatWave on AWS is different from HeatWave on OCI. So on the AWS side, we have actually added a bit more interactive capability on the console. So we have, for example, created a starter DB so that if you just want to give it a try it out, you just like a few clicks, you can create a DB system with HeatWave on it, and then with also sample data already loaded into HeatWave so that you can get it started really quick and very easy. Loading data from lakehouse into HeatWave. Also, we have like very easily, you can create the lakehouse mapping, point us to where you want to load the data from the S3 bucket, and then be able to load the data into lakehouse very easily. And also, we have recently expanded our region availability, right? So with now the additional regions that we have added is the Oregon in North America, as well as Korea Seoul in Korea. So now with HeatWave on AWS, we are available in 7 regions worldwide, and then we are planning to expand more in the future as well. So just on as a summary, right, we provide a single platform for both OLTP, OLAP, machine learning, generative AI across data that is stored on MySQL, as well as files on object storage, and then we are available in multi-cloud. Thank you so much.